Hello guys, in this video I want to show you a typical sensor for Arduino. It's named the CT or current transformer sensor that measures alternating current. They are particularly useful for measuring whole building electricity consumption or generation. The split core types such as CT, split core because it's splitted here. Core types such as this CT in this video can be clipped onto either the live or the neutral wire coming into the building without the need to do any high voltage electrical work. Like any other transformer, the current transformer has a primary winding or magnetic core and secondary winding. The CT transformer has a current output of 50 milliampere RMS. It's written here for primary 100, secondary 50 milliampere. So this 50 milliampere RMS equal to 70.7 milliampere peak and 141 milliampere peak to peak. So from here to here is floating current. And to get a right input for the Arduino, we need its logic level 5 volts, from 0 to 5 volts. So we need this burden resistance because this CT is outputting current. We need to transform it to voltage. So we need this burden resistance. We calculate like this: 141 milliampere peak to peak multiplied by 33 ohm. We get a maximum 4.666 volt peak to peak and put to Arduino to let Arduino calculate our current. If we were to connect one of the CT wires to ground and measure the voltage of the second wire relative to ground, the voltage would vary from positive to negative with respect to ground. However, the Arduino analog input requires a positive voltage. By connecting the CT LED, we connect to ground a source at half supply voltage. Instead, it is here 2.5 voltage will now swing above and below 2.5 volts, thus remaining positive. Resistors R1 and R2 circuit diagram here are a voltage device that provides the 2.5 volt source. The capacitor C1 has a low reactance, a few hundreds ohms, and provides a path for the alternating current to bypass the resistor. A value of 10 microfarad is suitable. We did this wiring already. We have it here. This is CT ports. This is the burden resistance. I don't have 133 ohm resistor, so I use 1 of 10 and 1 of 23, and they have 10 kilo ohm and another one 10 kilo ohm, and this is a capacitor. This is the wiring is like in here. As you see, we clamp our CT sensor around one wire and we connect our 100 watt bulb. Sense M11. In void setup, we call the serial and we set the Arduino pin. It's the analog Arduino pin A1, and we put the calibration coefficient. From where we get this one, it's easy. We make a CT ratio divided by burden resistance. In our case, our burden resistance is 33 ohms. So 100 ampere divided by 0.05 ampere divided by 33 ohms equal 60.6. we input it here. In the void loop, we calculate ERMS. This is the number of points taken. In the serial, we print the power. The power, apparent power, is ERMS multiplied voltage RMS. In my country, voltage RMS is 240 volts RMS, and we print the ERMS. And when we open a serial monitor, let's see when we plug our AC 100 watt bulb. As you see, we have apparent power 105 and ERMS 0.44, which matches very well with our physical calculation with the multimeter.